No, it's okay. Good morning to the speaker, Dr. Jagadeesh and Dr. Santosh, who have joined in. Today is the 68th webinar that we are having. In fact, Dr. Jagadeesh, who is scientist, ports and harbors, Khadakwasla, Pune, would be talking about hydraulic model studies in coastal engineering development projects. And introduction would be given by Dr. Santosh. Before that, let me just, for the benefit of the viewers, you would have seen in the invite, this webinar is organized by JSSAT Bangalore, ACCEI India, and the Ramco Cements Limited. In fact, about JSS as well as about the speaker, Dr. Santosh would be introducing. ACCEI, as all of you know, is a body of consulting civil engineers started in Bangalore, and in fact, ACCEI has been organizing number of events in collaboration with Ramco Cements, and over the last few days since the lockdown started, and before that also, we have been collaborating with ACCEI India during the Engineers Day celebration. In fact, as all of us know that it is a birth anniversary of Dr. Mokshagundam Vishwesharya, which we have been celebrating over the years. And Ramco Cements Limited, as all of you know, the company doesn't need introduction because most of you who have been interacting with us would know us better. Of course, today is a special day for us at Ramco Cements. Today is the 85th birth anniversary of our ex-chairman, Shri P.R. Ramasubramanian Raja. Ramco Cements Limited, which started in the year 1960s, had a number of technological advances at various stages of cement manufacturing, and we have been able to bring in latest technology right from mining till packing. Recently, what had happened was that based on the interaction with customers, over the years, we have seen that various types of concrete mixed designs and concrete were being cast in different exposure conditions and for different projects. So based on that, what we did was that we have customized our cement based on the concrete requirements. Like say, for example, we have the ordinary Portland cement, we have the Portland Pozzolana cement, Portland slag cement. So based on this, we have 12 different brands of cement. Like, for precast application, we have Ramco Superfast, which is meant for only precast. And for roof concreting, we have brought out a cement Ramco Supercrete, which is having a high rate of gain of strength with low heat of hydration. So that's the kind of advances that we have made. And Ramco Group, as all of you know, is not only in the cement, it is also in the area of wind power, because we have a number of wind farms in Tamil Nadu as well as in Karnataka. And we have been doing a lot of works in the area of wind power energy also. And we have Ramco Systems, the IT division of Ramco Group, which is again a key factor behind all the, you need to coordinate with the different departments and functions of the organizations. And that's how we have been able to come, with the collaboration with customers, we have been able to understand the Research and Development Center, which is an NABL accredited laboratory, which does a lot of work in the area of cement raw materials, in the area of testing cement, as well as we have a number of studies on concrete, various grades of concrete, various blending materials. So there is a group of concrete technologists and cement technologists who are working at our research center. And this has helped us to bridge the gap between the customers as well as ourselves, so that, we take this from a very engineering point of view. So with those words, let me invite Dr. Santosh BS to give a brief introduction of the college as well as the speaker. Over to you, Dr. Santosh. Welcome for this event. Please go ahead with your opening, with your welcome address as well as your introduction of the college as well as the speaker. Over to you, Dr. Santosh.
Thanks very much. I take this opportunity to welcome Dr. Jagadeesh HB, who is the speaker for our event. He will be speaking on hydraulic model studies in coastal engineering development projects. And also I welcome Mr. Anil Kumar Pillai, and I also thank him for the opportunity for JSSAT to have collaboration in hosting this national webinar. And also good morning to one and all, seeking the blessings of His Holiness Jagadguru Shivratri Rajendra Mahaswamiji and the present Pontiff Shivratri Deshikendra Mahaswamiji, on the behalf of Department of Civil Engineering, JSS Academy of Technical Education, Bangalore, in association with Association of Consulting Civil Engineer, Bangalore Center, and Ramco Cements Limited, I welcome you all for this national webinar on hydraulic model studies in coastal engineering development projects. So I'll just take a few minutes to share about the information about JSS. So the foundation is the Jagadguru Veera Samsthana Pita, which is established in 11th century AD at Suttur by Adi Jagadguru Sri Shivratrishwara Shivayogi, and it has an history of about 1000 years according to the sculpture. So Suttur is a village in Nanjangud Taluk and in Mysore district, and it is about 28 kilometers from Mysore city. So the founder of JSS is Jagadguru Sri Shivratrishwara. So JSS is very name triggers the nostalgia among technocrats in the state and also all over the world. The philanthropic and religious institution was founded 1000 years ago by Sri Adi Jagadguru Shivratrishwara Shivayogi Guru. So about JSS Mahavidyapita, which is located in Mysore. So it is a registered society which is offering educational services from crunch to PhD in various fields of engineering education like engineering, medicine, science, law, commerce, general education, culture and spirituality. It has more than 300 educational institutions, including 2 universities, which are located in different parts of our country and also in abroad like Mauritius, Dubai and USA. It is also running a special schools for differently abled at Mysore and Bangalore. Total number of students under JSS Mahavidyapita is around 1 lakh, and more than 10,000 employees are working under JSS Mahavidyapita. So at Suttur Math, there are about 4,000 students from different parts of India are given free education from primary to high school with both lodging and boarding. JSS Mahavidyapita Technical Education Division, it mainly consists of more than 20 institutions, including 4 engineering colleges, 4 polytechnics, 3 ITIs, 3 steps, JSS Consultant, JSS Research Educations, etc. And also JSS Mahavidyapita has implemented a hospital having 1,800 beds and host specialists providing services at Mysuru. So these are some of the pictures of JSS institution at Mysore and also at the different parts of the country and also in the world. So this is the JSS school which is located in Mysuru. So the engineering colleges, medical colleges, and about JSS ATE. So JSS ATE, the name as Jagadguru Sri Shivratrishwara Academy of Technical Education, Bangalore, was founded in 1997, and it is an integral part of JSS Mahavidyapita, Mysore. So JSS ATE is one of the premier institution in Bangalore, which is accredited, which is approved by AICTE, and it is affiliated to Vishweshwarya Technological University, and it is accredited by NBA branches under JSS ATE. Bangalore is accredited to NBA, and it has a gold ranking in QSI gauge. So about JSS Civil Department, it is established in 2009. At present, we are with an intake of 120, and we have the professional society membership from ICI, ACCI, and Builders Association of India. So these are some of the photographs of our exclusively, the building which is exclusively for Civil Engineering Department at the JSS ATE Bangalore. So the facilities, different facilities, the laboratory facilities. And now I take this privilege and honor to introduce our today's speaker, Dr. Jagadeesh HB, who is scientist at Ports and Harbours, CW&PRS, Khadakwasla, Pune. Is from Department of Water Resources, River Development and Ganga Rejuvenation, Ministry of Jal Shakti, Government of India. So he has his B degree in Civil Engineering, ME in Water Resources Engineering from Bangalore University, and PhD in Coastal Engineering from NITK Surathkal. He has 22 years of research, 9 years of teaching, and 2 years of field experience. His area of research interest are in the short wave propagation studies for the development of ports and harbors using a 3D hydraulic shadow basin, physical models, deck studies, and field studies for coastal data collection. He has published about 33 publications in various national and international conferences and journals. He is a life member of professional bodies like Institute of Engineers, Indian Society of Technical Education, and Indian Society of Hydraulics. He has contributed for the development works of new Mangalore Port, Chennai Port, and Kamarajar Port, Ennur, Tamil Nadu, Konkan LNG project at Maharashtra, and many fishing and minor harbors by conducting physical model studies, field studies, and deck studies. He is a block technical officer for Jal Shakti Abhiyan for Buldana district in Maharashtra. He has completed more than 50 research projects successfully at the CW&PRS, Pune. He has organized a number of training programs and conferences at CW&PRS. At present, he is a co-nodal officer for Coastal Management Information System, a Government of India project, and Kalsapur Dam Hydraulic Physical Model Studies at CW&PRS. So I take this honor to welcome Dr. Jagadeesh, and I request him to take over the session.
Thank you very much, Santosh, for an excellent introduction. Hello, ma'am. Hello, good morning.
We are able to hear you, sir. We are able to hear.
You are able. Okay. Good morning, all the participants. Thank you very much. At the outset, I just thank JSS Academy, and by just knowing the Santosh presentation, I just came to know so many things. I have heard of JSS Vidyapit, the society's service of JSS Vidyapit more than 1,000 years. It is really marvelous. Our respects and namaskars to JSS Sri Guru, and I am thankful to Anil Kumar Pillai and Santosh VS for a brief introduction about me, and thankful to JSS Academy, Ramco Cements, and ACC High for selecting me for this, giving an opportunity for this national webinar on hydraulic model studies in coastal engineering development projects. As I came to know about the audience, it is a wide spectrum drawn from students, research fellows, faculty members, etc. I remember about 2-3 years back when I addressed the JSS in their auditorium, I presented about coastal hydraulic environmental effect of the coastal projects. That time it was a direct eye-to-eye contact between the students and me. In webinar, we can approach more number of candidates, but only thing eye-to-eye contact from them will be absenting. But anyhow, let us hope it will be a good session. In this particular lecture, I'm just planning to cover keep the things very simple so that most of the participants should easily follow this particular thing, particularly when we say hydraulic model studies, flow of hydraulics, many complicated hydraulic flow equations, etc. will be there. But my field of specialization is physical model studies. The physical model studies, it needs a lot of precision and a lot of technology are involved in this. But once if I explain these things with some model videos, etc., the things will be easy to follow. In this particular talk, I will be just briefly explaining about the need of the coastal development and the importance of the coastal development, the scope that is involved in the coastal development, and how exactly coastal development projects will be very useful. That will be at the end of the session. Participants should be able to understand about the importance of hydraulic model studies in coastal engineering and the physical model, how exactly, what is the contribution from physical model. That is what we'll be sharing in this particular thing. So as I mentioned, coastal field, everybody will be, a lot of opportunities will be there for human population, for development, mainly because the industrial development, sea transport, power plants are developed there. And if you just see, around 60% of the world's population, it will be around in 60 kilometers away from the coast. So the coastal environment or any coastal development is very important from many points of view. And while doing so, it is very, very essential for a coastal engineer to give proper designs for the development works, whatever the development works, maybe it is sea transport, maybe a major project like a major port, or it may be a minor port, a fishing harbor, or it may be a power plant, industries. Lot of design aspects are involved behind each and every aspect of this. That is what will be presented in there. So in coastal, again, there are coastal environmentalists, there are coastal or offshore engineers, etc. like that. But in coastal engineering, it mainly deals, we have to concentrate more of the development works along the coastline, means where water body interacts with the land. There we have a lot of development works. Then the water is interacting with the land. There are a lot of complexities. Those structures, what we are constructing, will be having effects due to waves, tides, currents, sediments movement, and all this needs to be balanced in a proper way while we are designing these projects. So if you just consider in Indian context, you can just observe many developments are there all along the coastline in the India. Okay, and when we see, there are major ports like Calcutta, Haldia, then Paradip, Visakhapatnam, Ennore, Tuticorin, then Cochin, New Mangalore. All these are distributed over the peninsular area at some distances, so that each port will serve some interland. Okay, sorry, this in this particular thing, Andhra Pradesh or Telangana is not, anyhow, Telangana is not having any coastline. Andhra Pradesh will be having entire coastline of around 974, I think. State-wise distribution of coastal resource or coastal line is like this. Totally, we have a coastline of 7,500 odd kilometers, and the development works, whatever it is, mainly the port development or power plant development, etc. Those needs model studies, and all these major ports are the clients of CW&PRS. Central Water and Power Research Station. Our research station is around 105 years old, and all the major ports, they are the permanent clients of CW&PRS, wherein we give for any development, for any advanced development works of their port, they come and approach CW&PRS, and wherein we know from proper selection of site, we have given the port layouts and what works for them, what not works for them, all those things. There are many problems we come across when we are developing a port, and those will be presented to the brief. And mainly model studies where it is required. Model studies are required whenever we have complexities in the flow field. Whenever hydraulics, we have complexities in the flow field, we need model studies. So for that, we have to understand, first of all, the coastline. Then my next slide, it will be just like this. If you see the peninsular India, we have Arabian Sea on the west, Bay of Bengal on the east, Indian Ocean. These are the things. But once, if you just try to understand this, each and every coastal line is having its own features. Its own, like what is the bathymetry. Here, if you take, we have a mild slope. On the east coast, if you have steep slopes. That will be having effects on the waves or tides, etc. So it is better to understand. In my next slide, I'll just briefly tell about the main features of east and west coast. And this is the basic thing that one coastal engineer need to understand. And many phenomena mainly depend on these factors. So like bed slope, on the west coast, it is flat. Therefore, waves will be less because wave attenuation takes over a flat slope. On the east coast, it is steep. Therefore, the wave effects on the east coast, generally it is more compared to the west coast. Even this one continental shelf, that is what it is, around 250 meters, and it is only 20 meters. There are advantage and disadvantage. In east coast, you don't need a longer length of approach channel to be dredged for a channel for a port for the ships to come in. But whereas you have to dredge a very long approach channel in west coast for the same depth of ships. But you have lesser wave effects, but you'll have more wave effects on this particular side. Then currents. Tidal range is more on the west coast. As you know, in Gujarat and all, it is around 6 meters. In Mumbai, it will be around 4 meters. If you come down on the open sea, it will have around 1 meter or 1.2 meter. Hence, whenever the range reduces, it will be, whenever the range reduces, the tidal currents are also less. So whenever we design a project, any type of project, maybe a port development, fishing harbor development, thermal park development, or nuclear development, whatever it is, all these factors need to be considered and need to be addressed. Otherwise, there will be effects on the operation of this particular thing. Another thing, natural factors like west coast. is subjected to west monsoon only. But on east coast, you have southwest and as well as northeast. Most of the rain you can just observe on east coast. It will be northeast monsoon from October to January. And littoral drift is another effect. This whenever the waves are approaching on the sea slope or coastal line, it may be having an angle with which there will be interaction with the mud particles, and it will try to move the material either north or south depending on the wave angle at which. And this may be having a positive effect or negative effect that I'll be just taking up in the presentation later. There are other aspects is about the river. On the west coast, we have two major rivers which are contributing. On the east coast, we have most of the rivers are contributing to this. While the river joins this, lot of sand is just dumped into this particular aspect. Therefore, the littoral effect is more on the east coast compared to this west coast. And regarding the bed material also, normally on the east coast, fine sand, and here on the west coast, clay, silty clay. And these are the things which one has to understand as a coastal engineer when we are designing a project. The basic knowledge of a coast is very essential. So let me go. The four complexities, I just threw some slides. Why model is required? Suppose if you are building a dam, if you are heading up the water up to a certain extent, we can do the calculations by analytical methods. We don't just normally go for modeling. But whereas in coastal engineering, particularly, wave aspects let us consider. When the wave is coming from a offshore onto the shore, you can just observe the waves will be very simple to understand in the offshore. And wave transformation, where waves are coming from offshore towards the shore, you can just see there will be movement of the wave particles. Okay, this will be circular in path. But once if they come towards the shoreline, most of the time what will happen, this wavelength it decreases and wave height it increases, and it will become almost difficult for the wave to sustain its height, and it breaks. Once it breaks, there will be a lot of energy dissipation, and this flow at this particular region is very complex. That is what I was just telling. Whenever we build up whenever just a minute. See, the flow phenomena will be very complex in this we call it as breaker zone. So this particular zone is very difficult to just understand. For this, normally what we do, hydraulic models will be done, and through once if you just do your modeling work, these complexities can be well visualized and we can understand the things very well. And it is basically for a coastal engineer, it is necessary to understand what is offshore, shore phase. These are some technical works there. And tidal effects, high tide, the water rises, low tide, water reduces. While rising and this thing, there will be some flows front and back. So this is how, this is a typical sketch. When water is flowing towards this, you will have a breaker, a breaking effects, swash and back swash. While swashing, the materials which are there will be picked up by this. Depending on the angle with which it hits, the material may move front or back. So this is what you can see here, a typical sketch to understand the flow field. See, this is a fair wave base, we call it, wave base. Below this particular base, there will be no action of the waves. So for a ocean engineering offshore, there will not be much effects on the ground. But when you are coming towards the shoreline, there will be a lot of effects. You can see the wave currents, particularly off the wavelength. This is wavelength from amplitude to amplitude. Half of it, suppose if it is a 10-second wave, the wavelength may be around 150 meter, about 75 meter depth, up to 75 meter depth only, the wave particles motions will be affected on this. And this, when it comes towards the shore, it breaks and its effects will be more there. And if you understand, if you can just follow this particular thing, wave base, and when it comes towards this shore, you will have wave breakers. Then formations on the coast, you can just see there are many in the shoreline. There are many distinguishable parts like swash, back swash, wave breaking effects, wave processes, the formation of this. This will be a theory by itself. I'll not go much into this. Any coastal engineering books, they will explain. And the complexities of these things needs to be modeled. Mathematically, to model all these things, particularly wave breaking, etc., it is very difficult. That is the reason why exactly physical models plays a very important role in doing this. I'll just go through this. This is what exactly in NAFID. Now I play a video wherein you can understand how exactly coast is influencing on the breaches. Video can just play. Here you can see the breaking effects and the beach dunes. This is one of the video that I have recently made at New Mangalore port. The waves, when they are, you can't see the shape of the wave in the deep waters. But when they approach the shallow water, the wave height increases and the wavelength decreases and it breaks. When it is breaking, you can just observe it interacts with the bed material. And this is a process which will be taking for 24 hours, 365 days. From millions and millions of years, this action is continuously taking place on the shoreline. And this is what is making the movement of the bed material, maybe towards north or towards south or onshore, offshore movements, etc. And this is very important to understand the process, because without anything, this phenomena will be taking place from millions of years, and there is some balance in the coastline. Suppose a man-made structures, when you interpret this particular thing, interact with the breakwater, interact with the construction of something, the movement of the material will be arrested, and that time you will have a lot of effects on the coastline. There may be accretion on one side, or there may be erosion on the other side. That will cause a lot of difficulties. Particularly, you might have heard of Chennai port that normally coastal engineering takes. When Chennai port was developed, Marina Beach was not there. So when the Marina Beach was formed, on north side, there was a lot of erosion was taking place. That way, one way you have erosion, one way you have accretion. That will be difficult for the coastline to maintain this particular thing. We should have a proper design, and those type of design and the tranquility requirement inside the port for the ships to berth. All these things can be studied through hydraulic model, which I am just briefing it. This is on the south side of New Mangalore port, wherein you can see the wave breakers. On the deep water, you call that steady state. Here, the shallow water, you have these waves taking their shape and wave breaking. It will be having its effect on the beach material, moving front and back. Yeah, moving from this, I'll go to next slide. I think in coastal engineering, the type of problem that normally we just do at the Central Water and Power Research Station, the port layout planning. Port layout planning, it comprises of conducting either physical or mathematical model studies for this port layouts, and arriving at an optimal breakwater length, extent, then the approach channel, how exactly it has to face. And once if you develop a port, there will be material that you need to dredge. Most of the time we get a material which is not fit for use on the land side, that we may have to dump it in the sea. So that we have to have a strategy for dredging and disposable. In dredging, again, you have two types. One is capital dredging, other is the maintenance dredging. Capital dredging is that part while constructing a particular port in the beginning, you may have to dredge. That may compress up sometimes rock blasting also. But in maintenance dredging, since the sea is very dynamic, there will be a lot of material. Once if you dredge a channel to 15 meters, maybe after the next monsoon, it will have only 14 meters or 13 meters. Some siltation will be there. Again, for the ships to come and all, you have to just dredge it again back to 15 meters, so you get material, and that material need to be dredged, and that needs to be disposed at a particular site wherein that material should not come back. And while giving the strategy for disposal, we have to give such a location. It should not be very far off, and it should not be too near. If it is too near, the material comes back to the post. If it is too far, the cost of the dredging means the distance which it has to haul the dredger, it will be more. So an optimized needs to be done. For that also, we do either field studies or mathematical model studies, and we give options for this. For port layouts, mainly we do mathematical and physical model studies. Normally, for minor ports, mathematical studies will do well. For major ports, when you have a continuous development for years together, captive physical models need to be developed. That will be useful for years for all the development process. Then apart from this, there will be breakwater structures. It is the structural aspect of this. These are studied on the 2D models. Okay, in physical models, you have 2D models, 3D models. For port layout, it is 3D model. For breakwater constructions and its effects, it will be studied on 2D models. Like when the ship has to move inside the port and come out, ship will be having several, it may be 100 or 200 meters length, carrying so much of weight, and its engine to be half, and it's just to move inside the port. You need to have a particular idea how the currents in that particular area, under the current area with the tug, how exactly it can move into this, it can be pushed into the shipping berth, and how it will be taken out after doing its loading or unloading operations. These aspects can be studied mainly by mathematical model studies. Physical model studies were also tried, but it will be very difficult to not that lucrative. But with mathematical model studies, you can do that. And tidal inlets is one more thing, wherein most of the time when the inlets will be closed during certain times because of littoral depth, how to keep that inlet means exposed to the sea so that there will be brackish water in this region, fish ponding, etc. can be done. Similarly, shoreline studies, I just told that littoral drift movement along the coastline, where accumulation is there, where erosion is there, and what are the norms, how exactly you can just come over this type of problems. This is shoreline changes. This is normally done with mathematical model studies. Then coastline protection, seawall constructions or Grayan field. For this also model studies are important. What I mean to say is there are a lot of scope in coastal engineering, exactly, and different type of coastal studies we can take up in. This thing is the tools available for this solution for this are like field investigation, then physical model studies, mathematical model studies, remote sensing. So we at CW&PRS have all these facilities, and we choose for a client, we choose what type of for a given client, which depending on its requirement, we choose what type of study that can be fit into this particular thing, and the best solution we try to give. Always, wherever we just observe, modeling will be having its own limitations. When we do modeling, select a particular type of model, a modeler is more important than the modeling. Most of the time, when a model may give a results, it will give a good idea about the project. It will not give each and every aspect of this. If you want to have each and every aspect of the project, then you need to construct a prototype only, which is very costly. Okay, prototype testing will be done only for some special structures. But while developing ports, while developing minor harbors, etc., generally modeling is done. A modeler with his earlier knowledge, earlier experience, what has worked out for him, what is not working out for him, based on that, with the discussions of the field engineers, they will give solutions so that things can be working well on the field. Field studies, one of the input for the modeling is the data from the field. The field data is the most important part in hydraulic model studies. So in that data, we need for a wave model, wave data, then for tidal model, tidal details, then current details, then for sediment model, water sample, sediment concentration of that, and a number of factors that are required. Sometimes we collect each and every factors. Otherwise, sometimes for waves, for major projects, generally for 2-3 years, wave data can be collected. We can analyze it, and from which direction, what is the extent of wave that is approaching this, desired wave norms, etc., will be decided based on the field data. So field data is one of the most important thing. Our capabilities at CW&PRS, we can we have equipments for wave data collection like directional wave radar voice, current collections, then tidal gauges, Then water sampling we have our exclusive lab for testing water samples, soil samples we collect, beach samples we collect. And that once if you have all the data, depending on the type of model that you are going to adopt for a particular study, we will adopt it and we use the data. And the data is where the model will means your results will be good when your data is good. Okay, that is one thing about field data. And whatever we measure D in field, that is the most one. And whatever the other things that we do on the modeling, we try to calibrate or we try to this is the true thing what is happening in the field, what I mean to say. And in model there will be some errors based on scale effects or laboratory effects. There will be some errors. A modeler should be careful enough while interpreting the results from the model to the prototype. And in mathematical models, the equation, it is a set of equations. You will divide the area into the grids, and each grids you will give the values, and you will run. And this will be good for some tidal studies or thermal dispersion studies. It is good. Remote sensing, it is one more thing. If you have pictures of a coastal line for years, definitely over the years, if you have pictures, you can just interpret accretion is there, erosion is there. These type of studies can be observed very easily with the good data. Again, as I told, hydraulic model studies, basically you can classify into physical models and mathematical model. So my field of specialization is physical modeling. At CW&PRS, we have specialists who conduct mathematical modeling in a very good ways also. Depending on the type of projects, we suggest for the clients to go for a particular type of model. Normally in physical modeling, Freudian similitude models in coastal engineering for waves and tides are the common thing that we. Freudian similitude means mainly inertia and inertia versus gravity. Froude numbers is nothing but the ratio of inertia and gravity effect. So this should be similar for the proto and the model. And other viscous force or things we can neglect because that will not. We are giving an engineering solution for any project, not exactly. If you want to simulate each and every force, it will be difficult. It will be prototype only. It is possible to simulate all the things. But from engineering point of view, to give a good suggestion to the clients, we can have a Freudian model wherein inertia and gravity are these things. Froude numbers, if you simulate it, it will get. But in mathematical model, again, there are different sets of equations, different softwares that are available, particularly for like finite difference method, finite element method, volume based. Okay, some softwares, whatever is available, just at CW&PRS, we have MIG21, LitPack, Telemac 2D. Each and every model will have its own applications, and these with the higher computational capacity, these are the major fields wherein these are applied, like offshore or nearshore wave transformation, offshore or nearshore wave transformation, wave penetration in the harbor, ship maneuvering, tidal hydrodynamics. This presentation will be given. And mathematical model, these softwares are improving day by day, and these are also giving to a good extent good results. Most of the time for major projects also, initially some of the alternatives, conceived alternatives will be initially tested by mathematical model where scale effects will not be there. Then for the final design, when you finalize a particular project, when you're investing a major amount on a major port, etc., you will be going for physical models. The physical model is very essential, particularly for major ports, wherein you have continuous developments for years. Okay, that is how all the major ports, all the 13 major ports, they have maintained their models at CW&PRS, and they are maintaining at their own cost because they have that much of benefit. I'll be just explaining physical models in detail later in the course of presentation, wherein my work at CW&PRS is on physical wave models and why exactly they manage all those things, why do maintain the models at CW&PRS will be presented there. Okay, in as I told, in mathematical models, these are the applications field. What exactly I want to say is even people who are interested in programming, who are interested in computer works, etc., they can also work on coastal engineering with so many fields. It's some of the things like tidal hydrodynamics, like coastal estuarine circulation, that can be well done with a mathematical model. This dispersion of dredged material, Okay, this is a physical model. It is not at all possible if you just dispersion of rigid material at a deeper depth of 20 meter, how exactly it disperses. That is possible well with the otherwise field studies like radioactive research studies at the field you have to inject and you have to just test how exactly it is moving. So these things like mathematical model, field studies, or this other methods are complementary to each other depending on the type of study, type of end results that we require. Based on that, we are going to take up this. We select a particular study. That's what I can just say. So in ports, coming to our this thing, there are different types. There sometimes you have natural port, land is covering the waves, and you have a tranquil region, or you may have a lagoon type of port. It is an artificial port. Entire thing was earlier land. You just excavate and make a way for the ships to come in and berth there. Loading and unloading operations. Other port infrastructures will be developed. This is lagoon type of port. It is New Mangalore port. I'll be presenting about this as a case study. New Mangalore port, exactly what work at CW&PRS we do and why the manage last 50-55 years they are maintaining the physical model at CW&PRS. For each and every development, they are coming to us asking suggestions. They observe the things on the model, they visualize the things on the model and take benefits of that particular thing. Similarly, this artificial port at Tuticorin or Estuarian port at Kandla, these also we have maintained models at CW&PRS. So coming to physical wave models, particularly in here, in that again you have two types. Earlier days we used to have this regular wave model. This is the facility like we need to construct a model. After the construction of the model, we need to generate the waves. The wave data we will come get from the field. Whatever the data we measure through wave radar pi, we analyze it and we will select the design wave height for a particular model. That will be the input condition for the model, and that wave need to be generated on the model. For that, we have a system called a wave generator, a regular wave generator with a constant stroke of a particular frequency. The waves of same height and same length, same height and same period. But nowadays, in this, as you observe in this prototype in the sea, never we come across irregular waves. Always the waves are irregular in sea. It is random in nature. If you stand on a beach and if you see one wave will be higher, the next one will be smaller, the next one will be a little smaller, like that. Every 5 waves there will be a one big wave. Like it is a mix of different heights and different periods. Therefore, to get the exact picture of the nature, when you have to design a prototype, you need to have a random wave model. The various components of random wave generations will be like this, like a wave generator, then a servo actuator, a wave pedal. It just moves front and back by this servo actuator. And we have CWH, capacitance wave height recorders, which measures, it will be having two sensors. And depending on the wave height, its capacitance varies. That will be recorded in our computer room, and wave height at a particular location we get. This type of units we will have distributed over the entire model, maybe at 32 locations. When you are running a model, you get the results of wave tranquility at various locations simultaneously. This with a model video, I will demonstrate it later. Normally it appears like this, wave model. We just simulate the port area and we have the wave generators from the critical direction from where wave needs to be tested. Okay, for this model construction, we need to have various processes there. I'll just explain very briefly how exactly a model is constructed. In a physical model, I'll just skip most of the things. Most of the time, the processes that we just simulate on a physical model is refraction, diffraction, shoaling, and reflection effects. And mainly objective of this physical models for port development is wave tranquility in the abscess, which is one of the important things, and breakwater alignment and berth alignment, and sometimes sand trap in certain cases where littoral drift are more predominant. And normally the scale selection for a model is very, very important. It depends on various factors. I'm not explain the factors here. In any basic textbook, you can just consider, mainly depending on the cost that you can just incur. Normally for a wave model, 1:100 is good. 1:120 is also, you can just say nowadays we are adopting 1:120 because in a smaller area you can simulate more amount of space, more amount of prototype things, and you can get a good idea. Normally 1:120 is the scale. It is geometrically similar, both horizontal and vertical are similar. Particularly those civil engineers who are thorough with the dimension analysis and modeling, they might have studied about this scale models, what are the scale effects, etc. That is beyond the doubt scope of this particular lecture. Let me just move. Scale, normally what for physical wave models, we adopt geometrically similar scales. For tidal model, distorted one will be adopted for the reasons of its own. Then the boundary conditions for this will be wave data. What exactly the wave at a depth of around 15 meters or 20 meters, depending on how much area that we are going to, and the directions. If it is an all-weather port, means the port need to be operated for 365 days, then we need to consider the wave for the entire year, and then we have to just design critical from the critical directions. We have to and at CW&PRS we have major model, all the major port models. So this is about New Mangalore port model. As I was explaining, on the west coast of India, you have in the state of Karnataka, New Mangalore port model, New Mangalore port. And this port is called New Mangalore because there exists one more port on the southern side at the confluence of Gurupur and Netravati river. There is a Mangalore port which is around 400 years old, but this port was started around early 1960s. In early 1960s, when Lal Bahadur Shastri was the prime minister, he laid the foundation for this. And the port development, exactly what it does, and after independence, the importance given to this are the criteria. Zoom in. As you can just see, this is the New Mangalore port area. This is the New Mangalore port area. It is a lagoon type of port. The approach channel which connects the port to a depth of around 15.5 meter. So that ships of 15.5 meter can ship from deep water, they can enter into this. So in modeling, what exactly we do, we give the port layouts like breakwater, what should be its alignment, what should be its length. Then if you excavate the channel, in which direction channel should go, so that the shipping should be easy. When it moves from deep water into this, its berth, it should be, and there should be an easy access for this particular thing. And here you can see the Gurupur river, which is flowing all along the coastline, and it joins, and Netravati is coming from here. This is the Bangalore port. That's what this Bangalore port is around 400-500 years old. Now also it is there. It will be a fishing harbor now. It is a fishing harbor now. Ulal area, it is all erosion prone area. Lot of erosion studies all CW&PRS has conducted for this particular area. And about New Mangalore port, if you just zoom in. If I zoom the Mangalore port, it appears like this. See, these are the two breakwaters. The function of breakwater here is mainly to prevent the waves to enter into this harbor port area, port basin, so that you have tranquil water for the ships to enter into this and take berth, do loading or unloading operations, and after that you come out and go into this. These are the functional requirement. So basically, we need ships to enter from deep water. You have an approach channel which may be dredged to a certain depth, which is easy for the ships to move in. Okay, normally nowadays it is around 15.4 meter. The ships of 14.5 meter with a clear clearance of 1 meter enters the port, and it is functional now. This port is not developed at one stage. As I told, from 1964 till today, it is having different stages of development. Further, it has to develop still. Okay, in each and every stage, CW&PRS is involved, our model studies. So we have given the alignment of the models, we have given the alignment of the breakwater and all other functions like mooring forces, how exactly mooring should be done for this. All this have been done from CW&PRS. So these are the stages I was explaining, that from 74 to 80, it was only 10 meter. Then second stage. What I mean to say is it is continuously it's progressing, means we are increasing the capacity of this. While increasing the capacity of that, definitely there is a need to take up the study and give a proper design for the things. So this is the master plan. Now actually recently they have developed 2 berths on the western Dhaka. This is eastern Dhaka, and the Kudremukh iron ore berth. This is POL berths on the southern Dhaka, mainly MRPL jetty, and this virtual jetty also some 4 or 5 years back. We gave a final design for that particular thing, and there is a future development of berth in this region. For that also, we have conducted model studies. Continuously, we will be working on the model solutions, and those will be incorporated. Why the model study has been means the development of the entire port, if you take, it will cost not less than some thousands of crores it will be. Even for the development of a single berth, it costs 300 to 400 crores. So in that, a part is always necessary to just invest it on the model, because without the study, if you make a small mistake also, the berth may become inoperative and the entire functionality of the will not be served. Like multi-purpose berth, when they constructed about 15 years back, CW&PRS made a study. There was an intention of just extending the breakwater by 200 meters each. But after the studies on the physical model, we showed there is a lot of wave attenuation, which is the natural phenomena which is taking place in the berth, and the wave heights of this particular region is sufficient for bulk cargo berth like iron ore or coal, and they can just do that without extending the breakwater. That saved a lot of cost for them, and it is also functioning very well. And this is around 400 meters. 2 ships will be berthing here, and it is always occupied, and good loading and unloading operations are very easily taken. Even in monsoon season, though it is directly exposed to the westerly waves, operating point of view for bulk cargo berths, sufficient tranquility is there. That is only because of the model observation on the model. Even field engineers came and they just saw the model, they visualized it, and they agreed and they built. It is functioning very well from last 15 years. That way. And a lot of savings were also achieved in saving the length of the breakwater. The length of extension of breakwater will cause many difficulties also sometimes. Then now the proposed Western Dhaka, we have already conducted studies and given some results for them, how exactly they can go with their alignment, etc. The things are progressing, but nowadays these 2 container berths have been done. So in the model construction, exactly what we do. This is the port basin, and these lines, that's what you can see, are the contours from the prototype. Means from field, we measure the depths of the, when you just move towards the sea, the depth increases. We get those features, and those features, we will put it on the drawing, and these are all the dredge depth to 15 meter or 19 meter, depending on for which we are testing it. And that will be incorporated on the model. And when you construct the model, since it is an all-weather port, we consider the waves from west, northwest, and southwest. Means if it is 365 days operation, waves will be coming, approaching to this harbor basin from different direction. Hence, it is very much essential for us to conduct the studies from all the 3 directions and test the harbor tranquility, test the approach angles, and suitability for berthing. We need to probe. This is about a layout of a harbor. Recently we just had some construction work in our physical model. I will just show exactly how we just simulate a model. See, for example, these are the drawing contours on a grid, and this grid will be marked on the model, and we are going to mark all these grids and contours on the model. to very precisely. At CW&PRS, we have very skilled persons who can just do this type of work. So initially, we just have a model bed like this, completely. Afterwards, bed preparations, depending on the contour depth. Afterwards, from the bathymetry, initial bed preparations, it will be there. Afterwards, we'll have a grid on this. On the grid, we are going to mark each and every contours. Each and every contours will be made with the contour strip. We will have brickwork for the harbor works, wherever is there. And contour strips are made of different depths as per the field data. And the plastering work will be done to finish this. And we have hump profile for waves when they generate. You need a proper hump for simulation. That will be done in the model like this. Once if the model is ready, then it is like if you construct a good model, particularly physical model, if you construct, then it is a tool for you to play with it with different alternatives, to visualize the things, give suggestions, etc. Now I will show you a video clip of a model. It will be very, it may be interesting for you. It is very, you can just see the scale to this New Mangalore port model, which we are managing from last more than for New Mangalore since 1960s. We are managing models, and this particular model is a random wave model which has been developed by early 90s. Till then, we have regular wave model. This model, you can see, we have waves approaching from west, southwest, northwest, and the harbor basin entirely it is simulated. This is how it looks like after bed plastering. This is the approach channel, which the port dredged channel, and these are the center capacitance wave height recorders. This measures the wave height. Normally, once if we just construct the model to what exactly we have to do, it is a scaled down prototype. Means it 1:120 scale. Whatever that exists in the prototype with some boundary, we are simulating, and we fill the water to high water level or low water level at which we have to do the testing, and we run the model with the waves. By generating waves regular with once if you have a random wave model, you can run either with regular and random wave. Now we can just see how exactly the model behaves when you. This model is housed in a very big hangar of 45 meters by 72 meters. You can imagine this means the tune of the model construction, the scale. This is 1:120 scale. If you select a scale like 1:100, it will be still bigger. 1:50, the results will be good, but the model size it will be huge and it will become very expensive. Therefore, we optimize and scales chosen for this type of models, Freudian model of 1:120, geometrically similar. Once if we start wave generations, testing will be done from west, southwest, northwest, and we collect the results. And finally, we will be repeating it a number of times until we get a correct results. Means correct results means modeler will be knowing when exactly model is behaving properly. Suppose if I start my wave generator just now, and if I collect the data, definitely I will not get my wave tranquility of this. This has to run for few minutes. This has to run for few minutes. After running for few minutes, the model, the waves will penetrate into this. There will be a lot many effects like reflection effects from this, diffraction effects from the breakwater, then diffraction effect from these edges like this. And these are the model boundaries. Normally, in the sea, you don't have a boundary like this. This is all the scale effect. Means if you have a boundary, there will be reflection. To observe that, we will be just having absorptive surface, maybe meshes or maybe sometimes fine aggregates will be placed. Once if you run the model from a particular direction, you will be knowing how exactly wave penetrates, the direction of the wave, height of the wave at various locations. And by doing so, this is from the wave generator. And when you are generating the waves, it just travels from the generator towards the port basin. And while going so, there are many transformations that are taking place to this. Mainly, you can observe this is the dredged channel of around 15 meters. Most of the wave field goes out of the channel because there is a peculiar phenomena of wave attenuation or long approach channel effects that has been made use at New Mangalore port. And this is the reason why the breakwaters of New Mangalore port are very, very short. Means even now they have only 770 meters of breakwater, that to a depth of around 5 to 6 meters at the edge. I'll just go a little faster in this so that what exactly I mean to say is we construct a model. From the model, we take the various observations like wave pattern, wave diffraction effects, refraction effects, wave directions at different locations, then the wave heights at different locations of our importance. Then we frame our report for the project. We frame our report after observing all these things. We give all these observations into this. Means a lot of efforts are required and a lot of manpower is required for this. And it is a multidisciplinary field wherein we involve civil engineers, mechanical engineers for the design of wave boards, then electronic engineers for computer acquisition of data, etc. Okay. Now, coming back to this, I'll just move a little fast. See, this is how, if you take a pictures of when the model is running, we get a lot of wave patterns, etc. These patterns will be sketched. The wave observations will be made at a particular, if I want to develop some berth here, I take maximum observations here and I'll take the directions of the waves here. That is what is counting a lot for me, the area of my interest. And we will take at the other locations also the building of a berth here, what are its effects on the other thing. That is also observed on the model. And to a best possible extent, we get good results. Most of the time, we have compared it. Once, if you give a particular, do a model study, and afterwards, if you give it to the field, after the execution also, we take sometimes how exactly it is behaving. Most of the time, around 85 to 90%. 100% definitely matching is not possible through any modeling. More than 80% matching between be there. That will do. Factor of safety will always be there when we just conduct this type of experiments and give the reports based on the model studies. These are some of the views of the models again. This is our data acquisition system. Okay, we have, as I mentioned, random wave generation, data acquisition. So 18, sometimes 16 to 32, 16 or 32 or 8. Any number of channels you can have as you wish. But simultaneously, when the model is running, if I place my 32 probes at different locations, the data will be acquired once in every frame, and that will be stored in computer, and the data will be analyzed. After the analysis, we will just give the results. So one of the interesting projects recently we just is Coast Guard jetty. As you know, the Coast Guard. So this is the New Mangalore I had already explained, north breakwater, south breakwater. Coast Guard jetty, Coast Guard people, they use small crafts of around 5 meter or 6 meter draft is the required thing. In the absence of any jetty, they are right now using berthing in the this one MRPLR, Southern Dakar. Somewhere here they are temporarily using, or sometimes they will give to berth number 1. They take shelter there. But they wanted a special with they are protecting. They are the people who are protecting the coastline 24 by 360, 24 hours, 365 days. They are just watching this. They need a separate thing for their vessel operations. For that, when they had interactions with New Mangalore and Coast Guard, they had allotted a place which is not a commercial place for them. These are all the things which are already occupied. This location was given for them. Coast Guard office is somewhere located here. At CW&PRS, we studied recently for this particular study. I will just present about that. So their proposal was at this, but after discussing with them, we suggested an alternative location. That is all. I just wanted to say exactly, if they come with a proposal at CW&PRS, we just think of other things also. Sometimes we test the proposal, we give alternative solutions also. How exactly this particular proposal has helped Coast Guard people, and just brief. This, as you can see, the requirement of draft for this is only 6 meters. For this, if they want to build a jetty, they can't have their structures for 8 meters or 9 meters because the approach channel, because The approach channel, it is around 15.5 meter now. Now they want to expand it to around 19 meter. This jetty pillars, etc., they have to construct to around 25 meters depth. So that will become very costly. That is one thing. Second thing, when the ships of very high draft, when they are approaching this, the waves of the ship generated waves will definitely affect this particular when the ship moves here, the ship generated waves will incidents on the broadside incidents will be there for this broadside, and that will not be a comfortable zone for the Coast Guard jetties, for Coast Guard vessels to take. Therefore, alternatively, what we suggested is taking shelter of the existing north breakwater. You construct one more small breakwater here and you dredge it only to around 8 meter, have a small channel and you use it. It will be very near to your Coast Guard office, and as well the cost of these two, when you compare, there is not much difference between. This was a very good suggestion that they are considering. This is one part of the study, physical model, and afterwards also they have to study many things like how exactly the ship motion, navigation of this, berthing of the ships, siltation of this. This will be taken up by mathematical modeling. Means a project to complete, there are different types of studies. One is like wave tranquility studies on physical model. This was conducted, and when we conducted, the results are like this. Of course, we have provided one outer breakwater of around 625 meter, inner breakwater of 265 meter. These breakwater costs will not be much because it is in shallow water depths. When you construct the breakwater in deep water depths, if you want to extend it, it will be costly because it is 7 meter, 8 meter depth. It is starting from zero. You will construct up to 4 or 5 meters. Therefore, the cost of the breakwater is also not much. And the Coast Guard jetty was provided like this. This, what we have indicated is the tranquility results, the wave height at this particular thing. Generally, these are defined by Piang or Indian standards. Normally, for small crafts, it is 0.3 meter. If it is below 0.3 meter, they have comforts in berthing operations. When we tested it, we just optimize the lengths of the breakwaters so that this tranquility should be less than 0.3. That is what we have achieved. For that, it is 625. And we have, in arriving it, we have done so many tests. We have done repeatedly so many tests. Months together, we test it and we give these particular results. Once if these results goes to them, the wave pattern is also one of the thing, most important thing. Always the wave crests. There should not be any broadside incidence of the waves on the vessels which are berthing. Once if they are take the broadside, definitely there will be comfort of berthing will not be good. That is why that wave pattern also we will sketch on this. This you can just see with the video. Next video. This is the site where. This is how, when we just Coast Guard for exclusively for Coast Guard jetty, we have simulated inner breakwater of 275 meter, outer breakwater of 625, a small channel. This has been tested from west, northwest, southwest, and you have complex phenomena of wave here because the main approach channel of the NMPT is just adjacent to this. Because we are taking shelter of the north breakwater, we are saving cost here by taking shelter of north breakwater, but the same way the complexity of the wave field is there and how exactly it behaves. There may be a formation of a small beach on this particular side after this. These studies will be done separately by mathematical modeling, and as well as tranquility studies, we have cleared that particular thing. This is how it is at low water we are testing. We test at low water, we test it at high water, we take the wave tranquility results, and we optimize the lengths of the breakwater. This is one of the major things. So you can just see, anybody can just understand, anybody can just visualize on the physical model once if it is constructed. Normally project people, maybe from Coast Guard or maybe from a New Mangalore port, who are not much aware of modeling, they can come and visualize the things and they can give their idea. That is the best part of physical model. And that is how our strength lies in CW&PRS. CW&PRS is very strong in physical modeling. And what we charge is only what, it is a non-profit profit-making organization. We don't charge we don't make any profit out of this. It is all Government of India based norms of the rates will be there. Based on that, we charge to them. This particular project, since they have the model, it costed them around 15 lakh rupees for this test, for entire construction, testing, giving report and all. And that way, once if you have a model, definitely take advantage of that particular. Now, coming back to this, this is the site that this is the North Breakwater. This is the site exactly where we have just asked them to go for this. This is one more view of exactly we take the wave pattern, sketching of the wave pattern, the proposed jetty, any alterations for this, etc. This coast guard, just kidding. This is one more video clip is there in the field visit. That may be interesting. I will just show that and I'll just move for the next. A few more video clips are also there for different models because I have been allotted only 1 hour. I'll be just finishing this particular thing and I will take up questions from the audience or from the participants. This is how in the field operations, you can see the very tranquil region. There should not be much. This is the multi-purpose berth at New Mangalore port. The ship may be of a length of around 180 meters. It will be standing the bulk cargo like coal or iron ore. That's loading and unloading operations are going on. The wave incidents should not be from the broadside. It should be from this. This was a off season wherein you can see the tranquility, how tranquil it is. The more tranquility, the more will be the ease with the operation for the port people. And we are going towards the entry, means harbor entry, moving towards the sea. This was taken during the RAT studies, radioactive traces studies, when I visited New Bangalore port. So when you just move towards, on the right side, you can see the site which was allotted for Coast Guard. So when a ship moves in this, the ship-induced, particularly a big ship moves, ship-induced currents, ship-induced waves will have a lot of effects on that. That is why the reason why. This is one more model of Kamarajar port, which we recently developed with the latest system of random wave generation. Out of curiosity, I'll be just showing. See, this is how the physical model, once if you construct, whatever the development project of berth comes, very easily you can simulate it and anybody can easily understand the things. That is the most best part of it is. Anybody can just see how exactly it is, how the wave pattern it is, what is the tranquility, where exactly the tranquility limit is less, where it is more. Where it is less, you can have sensitive cargoes. Where it is more, you can go for bulk cargoes, these type of things. You can just and this is one more photo, which is means for this, these are the mooring thing. When the ship comes and stands here, mooring forces are also very important. Say how exactly it is moored for loading and loading operations. You have tied up this, we called this also by mathematical model studies. We conduct it at CW&PRS and give how exactly this need to be done. This is one more operation of this field photos. And normally, wherever possible, we give berths to be built on piers. When you have a pier instead of a solid structure, normally it will give the way for the water to vent. Means it can, the currents will not be affected much, and you will have waves can just dissipate on the sloping side. Normally, we advise them to go away sloping side so that this is at low water. At high water, water will be here. The waves, whatever it comes, it breaks here. There will be splashing action, and most of the energy will be dissipated here. And that way, the ship which is berthed here, that will be safe. Means you will have more tranquil region at this particular region when you have most of the wave and current passes through the berthing structure. As far as possible, we try to give structures on this instead of wharves, etc. in the open. This model clip, I think I had shown already. This also I have shown. I think I can just hand here. This is how I think I was able to convince some of the participants about the importance of physical model, how exactly we just simulate the model, how we construct the model, what support that we can give for the model will all be will all explained to the best of my extent in the available time. Thank you very much. If there are any questions from any of these participants, I welcome all you. I can just
Thank you.
take the questions.
Thank you, Dr. Jagadeesh. That was a very interesting presentation. Yeah.
Thank you. Thank you. Sorry, I have taken a little higher time.
No, it's okay. I mean, it was very interesting because, as you rightly pointed out, it is an interdisciplinary study as well. Coastal engineering, civil engineering. And another very important aspect was that you touched upon the physical modeling, which is by itself a very challenging part. And all the factors that needs to be considered was covered. In fact, sea and ocean has always been a fascination for me also. And, whenever ships come and the kind of work that goes behind all this is really very interesting to see. In fact, there are a couple of questions, sir. Mr. Parmeshwar Pandian has a question. He's a coastal engineer.
Yeah.
He says that I understand the CW&PRS as permanent physical model for many major ports. What is the design life of these physical models? I understand that, wave generators are mobile units because it may be difficult to. That's what he was asking about.
Yeah, I'll explain. In CW&PRS, for all the major ports, we have models. These are all rigid bed models. The movable models, we don't do now. That is very costly. Nowadays, even physical model, because of the labor cost intensive, it is very costly. We have rigid bed models. Only some for studies like littoral drift, etc. Now, sometimes we conduct injection by using a material like walnut shell, which easily moves on the injections. I think one of the slides, I have separate presentation for injection studies, how we do this accumulation, erosion, that qualitatively we give the do that. But mobile bed models are not there. Only rigid bed models we adopt, like waves and tides models. We have wave models, tide models, depending on the type of problem that we take. Mobile bed models are there for river engineering group, in river engineering, but it is very costly. For coastal engineering, every time you run the model, you have to change the bathymetry again, depending on this thing. So I want to just say that it is all rigid bed models.
Another question was using of sea sand, whether sea sand has been used for concreting.
No. That is not possible. It will become a moving type. We have rigid bed model. We use some of the material like walnut shell, which is very light in weight. There is a particular concept, NODA's concept. From that, we can just derive, depending on the wave height that we have in our model, it may be capable of taking or pushing the material during the wave breaking. So we have a particular grain size of walnut shell powder that we inject and we do our studies. If we inject sand or something, it will not move at all. Its density is very high. It settled down. With the wave breaking effect, the energy of the wave breaking, scale down wave breaking on the model, it is unable to take out the sand. Equivalently, we will by NODA's coefficient.
Mr. AVH Hadimani, your ex-colleague from L&T, has sent.
Yeah. Thank you, Hadimani. I'm very much. We are very close. We are classmates. Yeah, thank you.
And another question is that do the whirlpool reduces the magnitude of tides?
Whirlpool reduces the magnitude of tides. No. According to me, tide is it is an effect because celestial bodies, attraction between the sun, moon, and the earth. Okay, it mainly depends on that particular thing. Tides have their own effects, particularly in the estuarian. The tidal effects are governed by, those are very different factors which go, not by the world.
Okay. Is there any future for coastal this thing and all that? There is a question on that. I think probably by the students. Coastal engineering, offshore engineering. What are the future that is available?
Definitely. In the beginning, I just mentioned what are the so many factors that need to be studied in a coastal engineering project. As you can see, many development projects, maybe thermal plants or maybe other nuclear plants, ports construction, all those things are coming along the coastline. Only thing we have to just dig into this. The coastal field, I did not in the beginning, it just started in 1930s as a separate this thing. After 50s, people took it as a separate profession. So theory development and all, still many things have to be done. Particularly, I told you about wave breaking. There is no theory which just says what is wave breaking, etc. And for marine construction, there is continuous scope. A lot of scope is there. Only thing, people should take much interest in that, and basics have to be developed. Basics have to be developed. Marine construction and marine designs are specialized things. Normally at undergraduate level, those will not be taught to the extent that is required. If they involve themselves in marine engineering, I think definitely scope is there in this.
And the other question is, how many types of coastal protection between land and sea is available?
There are different types. Basically, we classify it as flexible or sometimes rigid constructions, and there are innovative methods people are using. Okay, like flexible, sometimes if you find erosion, if you just take a material from accretion point and if you dump it here, soft measure we call it. So that is the best way normally we suggest. The second one is constructing a seawall. The bad part of constructing a seawall is you can protect some area, but the adjacent area will start eroding, and there is a continuous process. You just keep on just constructing it. Otherwise, construct a Grayan field, a battery of Grayans, have some sand inside that. So energy basically for protection, the energy of the sea, means sea water, maybe waves or tides, will be more on the land. That need to be dissipated. Maybe having a spreading beach or constructing some sea walls, or soft measures like dumping the material dredged from the accreted place, like Vishakhapatnam port, where they have accretion on the one side and erosion on the other side. From the south side they collect, on the north side they will dump. So you can manage the balance. The best is soft measure, but hard measures are required, because everywhere it is not possible to have soft measures because of the cost involved.
Economy is also a major parameter.
Yes, that is a very important. If I ask a fishing harbor to have dredge and dispose on the other side, it is very difficult, not possible at all.
Another question is, are we using Axolo software for offshore structure? And if not, when we will be able to adapt?
So, actually, offshore structure, it's a part of ocean engineering. Normally, we won't take up works on ocean engineering. That is, there are different specialists who take on ocean engineering. Most of the works at CW&PRS is in coastal engineering, which are near coast. Offshore structure, yes, there is scope definitely at IIT Madras. There are not many works that have been done. I think those people are competent to answer this particular software market. You have many number of softwares. We have a number of softwares, particularly offshore. We have not done much, and we have plenty of works on onshore construction, means coastal engineering field. That's why coastal engineering and ocean engineering, they are altogether in different aspects. I'm not particular.
Dr. Ashwath from ACCI Bangalore has sent his greeting, and he has said that it is a good presentation. It's been a long time since he has met you, and it has been very interesting.
Okay, thank you, Ashwath.
What about sediment transport? Views on sediment?
Yeah, sediment transport, most of the time we are doing it by mathematical modeling, hydrodynamic models of mud transport is there, sand transport is there. Those models, we have experts in CW&PRS who are working on that only. They need a proper data from the field. Once if they get proper data as the input into their models, definitely good results have been given. Here, actually, no model. There are limitations, many limitations in either mathematical model or physical model. There are limitations. The data is one thing which really governs the end results. For siltation or for mathematical model, you need to give proper current data, proper sediment concentration data, then soil samples, its details. Unless then they suitably they can conduct the studies, and good results they can give. Many times we improve upon by giving the results, testing in the prototype, then take the lessons from them. I can just say always, more than modeling, a modeler is important. How exactly he interprets the model results to the prototype, that counts a lot in modeling. Modeling is an art, and experience, and particularly visits to the fields. At CW&PRS, we visit the sites very frequently, and we just learn many things from the fishermen many times. They'll say the current is like this during different seasons. There may be reversal of currents, all those things. Then if we measure, we will get, means we have to learn from those, because we are not at sea always. Those people who are at sea, those people, from them, what has been worked for a particular site. I can say I just presented on East Coast, how is the coastal region, on West Coast. There are not many difference. If it is a project is success on East Coast, means that may not be a success on the West Coast. That may be a failure. For particularly in coastal engineering, there are so many uncertainties that if you give a particular problem to an engineer, or if you give to 10 engineers, 10 will come out with 10 different solutions, and each and everything will have its own advantages and disadvantages. We have to consider based on our experience, which is the best one, which is having minimum number of disadvantages. Any project definitely will have some disadvantages also. Yeah.
Last one more question, sir. What about the grade of concrete used for seawall construction? What are the techniques of concreting? I think that would be a separate subject by itself.
Yeah, I am not a competent person to answer this question.
Because one thing is that in IS 456 also they have classified it under extreme condition.
There are constraints, but since the
I think that is subject by itself, because you have to consider durability and all that, compressive strength, durability, or so many parameters are there.
Many parameters, yes. As structural engineers, people will be knowing better than this.
So thank you so much, Dr. Jagadeesh. Tomorrow, one more before I give it to Dr. Santosh. Tomorrow there is one more webinar at 4 p.m. and that would be a webinar on various aspects of a building construction. And we have designed this program for customers as well as construction professionals who would like to plan their building construction effectively. So we have this webinar tomorrow at 4 p.m. So Dr. Santosh, would you like to add some more thing? Yeah, over to you.
Yes, sir. Sir, it was a very nice presentation. And we are giving feedback that it was a very good presentation and they got a very good information, which, as you know, that these are the things which we can't find it in our textbooks also. So many of the things which you have covered it. So on the behalf of JSSIT Bangalore and ACCI Bangalore Center and Ramco Cements, we heartily thank you. In spite of your busy schedule, you made your time to present this topic. Sir, shall I proceed with the vote of thank?
Thank you very much. At the outside, I thank all the authorities, the organizers, JSS Vidyapit, then Ramco Cement, ACCI, I think all these for giving an opportunity. To the best possible extent, I tried to cover, but coastal field as it is very vast, as I said. True. And I think people could make out at least what is modeling, what exactly in the model, contributions of the model to the development in the coastline. Okay, and if I'm able to make out that, reach the people, that will be good. The given time was.
You were able to give an overview of that, sir. It was very.
Thank you very much for all, and I thank Director CW&PRS for permitting me. Normally, we get permission from our director for presenting our things. Director CW&PRS and all the staff members at CW&PRS has contributed a long in developing all these things. And our institute is 105 years old, as I just mentioned. In coastal engineering, last more than 70 years works have been done. Right now, I showed Mangalore model. Since 1960s, people are working on this. When one advantage of joining CW&PRS for the youngsters, we get each and everything of a port. Means we don't take a project as a particular focused on project. If you develop that particular project, what is the history of such developments in this? So that will give, we have a lot of reports, technicalities of this, what has been worked for a site, what has been not worked. That is the reason we are family doctor major ports, most of the major ports, and the contribution from all our seniors and their knowledge they transfer to us, and our knowledge we transfer to our next generation. That's how it's keep moving. And the solution from CW&PRS is always appreciated by our clients. That is one big thing that I want to just thank you very much.
A lot of encouraging comments from the students community also.
Yes,
we were able to get a very good idea about the entire aspect. I think it would have given, it was an eye opener for the student community, because from the way that I could see the comments,
okay,
it's really interesting.
Thank you
so thank you so much, sir. And thank you, Dr. Santosh, Dr. Jagadeesh, and Mr. Suraj, who is our host and who has been taking so much pains for organizing this. Thank you so much, and all the best. Stay safe. Thank you.
Okay.
So
Thank you
we
very much.
sign out for the
Yeah,
webinar.
Santosh.
Thank you
Yeah.
so much. Thank you.
Thank you.
Thank you.